Good morning. It is 7:30 a.m. here in Denver. It's time for the daily coding problem. Today's problem comes from LeetCode. It's on their list of top interview questions. Let's go take a look at it now. This one is labeled as easy, so I don't anticipate a lot of struggle here, but you never know. These can be pretty tricky sometimes. So let's read this together. Let me turn off spell check. Okay. Given an array of integers, return indices of the two numbers such that they add up to a specified target. You may assume that each input would have exactly one solution, and you may not use the same element twice. And then we have our example. So given the numbers 2, 7, 11, and 15 and the target of 9, we've got to find two numbers in that array that equal 9, right? Which is going to be the first and second, it looks like. So we return 0 and 1. Cool. And that seems pretty straightforward, I guess, huh? I wish they gave us more examples, because now we're going to have to make some up. Because I don't think this example is going to catch some of the edge cases I'm thinking of. So like another example is something that could be potentially tricky, right? Let's say we have 2, 2, 4, and we want 4. We're going to want to return 0 as 1 as well, right? What's another interesting case? Because this one's interesting because we have two of the same number, right? So that might affect how we store things. What's another scenario we can test here? Maybe let's make something that's not 0, 1. How about that to start off with? And maybe we do 9 and 0. So we test adding up a 0 maybe. Maybe that could be something tricky. So this would be 1 and 3. Cool. Let's start with those 3 tests and go from there. Might be enough to get us going. So I'm just going to copy all these and I'll open up a new file called solution test. And we'll add these test cases in here before we start thinking about writing some code. So we'll use Minitest auto run for running our test for us automatically. Got a little Vim shortcut set up that's going to run our tests. And then we'll use pride, and that gives us color in our output. And then we also need to require the file that we want to test, which is going to be called solution. And then we need to describe our solution. And we need to name our method. So this is going to be, we're giving an array, we're giving a sum, we need to find the two numbers. We'll call it find2. It returns the index of the two numbers that add to n. Pretty straightforward. And now we'll paste in that stuff that we copied earlier. We have some test cases. So given this, we expect this whole line can go away. We expect 0, 1. Perfect. So these are our 3 test cases we want to take a look at. Let's turn them into a test. I'm going to write a little Vim macro to help us because we got to do this 3 times. I'm pressing QQ to record what I'm doing here. So we're going to want to do solution.find2, and it's going to take numbers and I'm actually going to call this K, I think. We'll call it sum. We'll call it result. There we go. Good. That looks good. Okay, that's what we're running. And we expect to get back this. That looks good. Yeah, there's our test. Let's end our macro recording and see if that works. Cool, it's working. All right, let's do it one more time. So there's our 3 test cases. Returns the index of 2 numbers that add up to the result. We rename that variable, right? Okay, sweet. I think this will get us going. So let's run this test now. Of course, we expect this to fail. We haven't even created our file yet, right? And that's what it's saying. We need to create our solution. So we'll do that now, and we'll create the class. Jump the gun a little bit here. No method find2, which we can add. And we know this takes 2 parameters. It takes our numbers, and it takes the sum that we want to add up to. And missing keyword sum. Why is it missing keyword sum? Because I called it result. That's why. Sweet. Okay, now we actually have to figure out how we're going to solve this. So we got our first failure. So what are we going to do in here? So what I'm thinking with this, you know, one solution that would be really, really inefficient would be to walk through the array. I think this is probably n squared, right? I'm not great with these complexity things, but this seems like n squared to me. We start at 2, and then we check the entire set of numbers for anything that we can add to 2 that gives us 9. If we don't find it, then we go to the next number. We start at 7, and we walk through the rest of the array and look for anything that we can add to it that equals 9. And then we do the same with 11, blah, blah, blah. So that means we're going to run through this array a bunch of times, right? That's not great. So a better solution, I think, would be to walk through each number. So just walk through the array from the beginning to the end. And as we do that, we'll keep track of the numbers we've seen in another array. So for example, when I see the number 2, I'm going to have an array called scene, and I'm going to store scene of 2 equals true. And then when I see the number 7, I'm going to say scene of 7 equals true. And then scene of 11 equals true, etc. And as I do this, as I'm walking through the numbers array, marking the things that I've seen. The reason why this is cool is because then we can instantly look up any number we've seen, right? So as we walk through the array, then now that we're keeping track of these things, I can check at the first number of 2. I can say, have I seen the result minus 2? Right? Have I seen that? If I have, then we found a solution, right? And what that means is we're going to be able to walk through this numbers array one time, and that's it. So it'll run a little bit faster. The trade-off here between what we just talked about and this other solution is we're going to have a little bit more storage, right? Because we're going to now need to store this set of numbers that we've seen. So our storage is going to be potentially just as large as our numbers array. So we have more storage, but it'll run a little bit faster. But usually that's a good trade-off. Sometimes. I mean, I guess it depends. Maybe it doesn't matter at all. Okay, let's do that. So we have our scene. This is where we're going to keep track of what we've seen. And you could use a hash here as well. I'm using an array just because our keys are numbers, so it'll work with numbers just fine. So we'll do numbers.each do number. And remember, the first thing we want to do is we want to see, okay, have we found 2 numbers that add up to the result? So have we seen the result minus our current number, or if we're looking at this first example, have we seen the number 7? If we've seen that number, then we want to return the, I just thought of something. Okay, so instead of storing true at this index, we're going to store the index that we saw it. Does that make sense? So instead of our example of saying, instead of storing scene of 2 equals true, we're going to store scene of 2 equals 0. We're going to store the index that we've seen it. And where like scene of 7 would be 1. Okay, that's going to make this next step a little easier. So if index sum index, and I just realized we're going to need our current index as well, right? So let's do each with index, and we'll call this I. And we'll call this other I. So if we've already seen a number that will add up to a result, we're done, right? Let's go ahead and return that. Because remember, we can assume there's only one result, and that's all that matters. So we're going to return, and because we're going through numbers from beginning to end, we know that other I is going to be less than I, so we can return that number first. So we'll return other I, and that's it, right? If that's not the case, then we just want to mark this number as being seen. So this will be scene of number equals I. I think that's it. And then if we get to the end and we haven't found a pair, then our README doesn't, our problem doesn't say what we're going to do here, but we can kind of make up our minds, right? I'm just going to say nil is fine. So if find2 returns nil, that means, hey, we couldn't find a solution. So let's run this and see what happens. And it works. Okay. That was super straightforward, wasn't it? Holy smokes. That only took us a few minutes. Well, how could we improve this? I mean, we can rewrite this a couple different ways. I actually like how it's written now. It looks fine, right? Another way to do it would be to put this all on one line. That's pretty common. And, you know, we could have something like this, but I don't think that reads any better. So let's not do that. Yeah, I think this is fine. We can also do like a ternary here, right? Let's see what that looks like. I kind of like just to type stuff out sometimes and see what it looks like. So we could do that. And then, yeah, that's going to make our line really long. I don't like that. You know what? This looks good. This looks good. We'll run it again just to make sure I didn't mess something up. Are there any other test cases that we want to throw in here? So we've got adding 2 of the same number. We've got adding 2 different numbers. We've got adding 0. We can test our nil case, right? So we can write refute. So this is saying we expect it to return nil. If we try to find 2 numbers that add up to 9 and that's not the case, that should return nil, right? Expected 1, 2, 0 to not be truthy. Okay, so that's not what we're doing. It's actually just returning the numbers array at the end of the block, right? So good thing we added that test. And what else? That seems pretty good. Seems pretty good to me. We can try multiple sums. Let's add that as a test. And then I think we're done. So let's add, we're trying to find the result of 4. And we've got 2, 2, 2. So there's a couple different possibilities here. We want to only return the first one. So we're going to make that, let's add some padding onto here. Okay, so we want to return 1 and 2 in this case. 1 and 2. Okay, cool. So I think we're done. Let's go ahead and add this into a commit. Looks like we haven't actually added our README either, right? So let's add that. Looks like we have a typo on our README, actually. Oh yeah, we've got this crap we added. Let's delete this from our problem. No one else needs to see that stuff. Okay, so we'll add our README. This is the problem we just did. Good, looks great. Add exercise for today, which is the 6th. Very good. And now we have our solution to add. So that looks good. And that looks like we've got a couple extra lines at the bottom. Delete those. Good. Okay, that looks great. Add solution for today. Cool. Push it up. All right, and we're done. Easy peasy. I love those. Those are good ones. Okay, so we'll pick up another one tomorrow. It might come from LeetCode. It might come from dailycodingproblem.com. I'm waiting to get the email for that one today, and I'm looking forward to it. Thanks for joining me today. Bye.